Lines a lot today and a transversal. So one of the first things that we'll be going through is what is a transversal. And then seeing what the angles are called that pair up in the lesson today. So those are the terms that we'll be going over. Okay, so you see a big chart on the 3-1 notes. Transversal is the first term. And that picture will apply to all of the examples that you're doing. So maybe that diagram off to the side in your notes. Okay, that diagram has two lines, R and S, and number the angles on your picture like they are up there. Otherwise your notes are going to be mixed up. They're not going to match up correctly. Now the terms exterior, interior, exterior are there to help explain some of the terminology. And what they're doing is interior means between the pair of lines. Interior, inside, so between those two lines is the interior portion of that diagram. So then if you have angles that are not in that red section, they're exterior angles on the top and bottom. And that will show up in some of the vocabulary terms. All right, so there are a lot of angle pairs that we can make on this diagram. And when I talk about pairs, we're not talking about linear pairs or vertical angles in our lesson today. What we're doing is taking one angle at this top intersection. So out of 1, 2, 3, 4, we're going to have one of those angles identified. And then out of the bottom intersection, 5, 6, 7, 8, there's going to be one of those identified in each of the things we're looking at today. And the certain ones that you pick are going to be called corresponding angles, alternate interior angles, alternate exterior angles, or same side interior angles. So we're going to work on that vocabulary. All right, so if you've gotten all those notes down, then you can focus in on what it's saying and try to understand it. Okay? All right, first of all, what a transversal is. A transversal is just simply a line. It's a line that intersects other lines. And the way that it intersects is it's intersecting at different points. So it intersects line R here and line S here. We don't want to imagine a asterisk where all of the lines intersect at one point. Okay? So we need a pair of lines separate and then a transversal cutting through them. How many angles are formed in that diagram? How many angles are formed? How many did you number? 8. There's 4 up at the top and there's 4 at the bottom. Okay? So it makes a total of 8 angles. It does say that the lines have to be coplanar, so you can't start out with skew lines and then have a transversal. This kind of diagram just doesn't really lend itself to that. So we're having lines that are on the same plane. They don't have to be parallel for the beginning of our lesson today, but 2 lines and a transversal. So how do you know which ones are corresponding? Well, they gave you an example of 1 and 5. 1 and 5, that's one pair of them. There are others. How they pick those out, they are on the same side of the transversal, which is line T in our picture, and they're on the same side of lines R and S. Now, 1 and 5, they'd be on the left side of the transversal. 1 is above line R, 5 is above line S. So I would describe angle 1 as the upper left of this intersection, and then 5 is also the upper left of the bottom intersection. So 1 and 5 was an example. What would be another example pair? 2 would be corresponding with 6. 4 would be corresponding with 8, and 3 with 7. Okay? So there are 4 pairings of corresponding angles. Now for some reason, corresponding angles are the ones that students can't remember and they get mixed up on. So do you understand that they are in matching positions, like upper left, upper left? It's not that they're in matching as far as like flipping it over or folding. No, it's just sitting in the same position at this intersection and then at this one. If you trace angle 1 and angle 5, which I don't think that my screen's going to leave it up here very long, but angle 1 and angle 5, what letter do they form? What letter was there real quick?
E,
F. It was kind of an upside down F. Corresponding angles, if you trace both of them, will form a capital F look to it. Might be squished or something, but kind of an F. So if you want to put by your notes that this makes an F, that would maybe be something to add. I'm going to try and figure out how to get this to write and stay on it. I might have to switch programs, is my problem. Okay, alternate interior angles. Okay, they gave you an example like 3 and 6. So looking at 3 and 6, it says they're not adjacent, so they're not hooked together at the same vertex. They are on opposite sides of the transversal. So 3 is on the left side of the transversal, 6 is on the right side. And they are both between lines R and S, so they're on the interior of that diagram. So angle 3, angle 6. If you trace angle 3 and then 6, again, if you want to look quick, a letter, Z. That stayed a little bit longer that time, maybe. What would be another pair of alternate interiors? 4 and 5. And again, if I trace those, it makes a Z. That Z looked a little bit more normal. All right, alternate exterior angles. Again, the alternate means that it's on different sides of the transversal. So one's going to be on the left, one on the right. But now they are exterior angles instead of interiors. So in the white region, not the red region. So 1 and 8 was the example given. Another pair would be 2 and 7. Alternate exterior. And then the last one is same side interior. So go back to the red region in your mind. On the same side, or sometimes it's called consecutive interior, but our book uses same side interior. Same side of the transversal, but on the red section. So angle 3 and 5. 3 and 5. Trace those. What letter does it form?
C.
C. And then another pair would be 4 and 6. I wonder if I hold it there, does it stay? As long as I stay in contact, it'll stay. All right, same side interior. Now, I do a lot of abbreviating, and you probably will too, but we need to, I use CA for corresponding angles, AIA, alternate interior angles, AEA, and then SSIA. So you'll see me writing those abbreviations. That's what I'm meaning. All right, let's go to the next screen. See if you can pick them out on a different picture. All right, so either on your paper for notes, or if you want to grab a marker board. Just a little bit of battery, but it's anyway. All right, corresponding angles. There could be 4 possible answers here. Hey, Anthony, what did you have for the first one? Corresponding. 3 and 7, yes. I had 1 and 5. Could also be 2 and 6, or 4 and 8. Do I need to repeat any of those? Okay, alternate interior. Michael.
Eagle 4, Eagle 6.
4 and 6, correct. Or I had 3 and 5. That's another pair. There's only 2 possible pairs because you can't use the exterior angles. Okay, letter C, number C, whatever. Alternate exterior angles. Kelsey?
1 and 7.
1 and 7, or 2 and 8 would be the other pair. And then same side interior angles would be what?
Morgan.
4 and 5, yes, or 3 and 6. Any perfect scores? Get them all right? Okay, so do we need to do another diagram? No? Okay, let's go on then. There are some questions that will have more parts to it, and so there's going to be more than one possible transversal. So these are a little bit harder pictures. Okay, what we need to do is, it's going to ask us to identify which is the transversal. So this hint that was up here said, locate the line that connects the vertices of the angles that you're looking at, and that will tell you which is the transversal. So pick out angle 1 in the picture and angle 3. What line connects their vertices? Is it line L, M, or N? Jacob? L. Okay. So here's my transversal. Then angle 1 and 3 would be what kind of angles? Are they corresponding, alternate interior, or alternate exterior? So you're ignoring this part of the picture. And I'll tell you what I do in my mind is I have to kind of take these lines and straighten them out a little bit so that they're more kind of lined up to help me figure out what kind of angles they are. So 1 and 3 would be which kind? Think they're corresponding, alternate interior, alternate exterior, or same side interior? Write it on your board. It's kind of weird that if I hold it there, it stays. So there's your transversal, on the bottom part of the picture. 1 and 3, what kind of angles are they? Another tip is if one of the angles is interior and the other is exterior, there's a good chance that they're corresponding. Okay. Show me your board. Okay, I've got 3 different kinds. Okay, majority of corresponding, and that's correct. Not alternate interior or exterior because if you think about the pair of lines, 3 is between the pair of lines. Show me your boards. Line M. Okay, and then we got what kind of angles? Okay, I've seen all correct, so, well, no, not quite all correct, but alternate exterior angles. Okay, I think I had 1 or 2 who say interior, but it's exterior. Okay, so if there's more than one possible transversal, figure out which one is the transversal, ignore the other part of the picture, and that will help you focus on what you need to pick out there. Okay, the section 3.2 relates to this same, or these same pairs of angles, but we're gonna create them with only parallel lines. So I'm gonna have you do a little bit of an exploration. Got some line paper? You can get the iPads out of the way, because we actually need your protractor to do this little experiment. With this? All right, good. Okay, the lines are parallel, and what we're doing right now, they were not parallel in the ones we were doing before. Okay? So we have some relationships that work with parallel lines. The first one is called the corresponding angle postulate. That if 2 parallel lines are cut by a transversal, the corresponding angles are congruent. The hypothesis will be that same picture for all of these theorems, because all of them rely on there being parallel lines cut by a transversal. So if you want to draw that once in the hypothesis, and then just kind of like copy it on down. But notice in the hypothesis, which is the if part of our statement, if 2 parallel lines are cut by a transversal. So what on the picture tells you they are parallel? As you're drawing it, are you getting the parallel arrow there and the parallel arrow there? Be sure you put those parallel arrows in, because the hypothesis says if the lines are parallel. If they're not, you can't use this postulate. So if the lines are parallel, the corresponding angles will always be congruent. There could be 4 things we can get from that. We can get angle 1 and 3 congruent, 2 and 4, 5 and 7, 6 and 8. So there's 4 possible conclusions to that theorem, or that postulate. looking back at what you measured, I think the next one is alternate interior angles. What kind of relationship do the alternate interior angles have on mine and on yours? Are they also congruent or do they have a different relationship? Alternate interior angles. Are they congruent or are they something else? Alternate interior angles. Congruent. So the next one, it's a, oops, looks like I had an example, sorry. That looks like I had two examples, I'll come back to those, I guess. I was thinking I had all the theorems first. 3 examples. All right. There's what I was talking about. Getting a little bit ahead of myself. Okay, the alternate interior angles in our picture are also congruent. Now, why is this one a theorem? What's different about a theorem compared to a postulate? You really can't. So the first one out of what we're discussing here was the postulate, and then these other ones are theorems because you can get these proven based upon the first one we talked about. So alternate interior angles would be like angle 2 and angle 7, angle 3 and angle 6, they will be congruent. Now, I'm going to back up to those examples that I skipped over. Because without doing those, maybe the rest would be kind of difficult. Well, it looks like it's jumping all over as far as my advancing it. Okay, on this one, find the measure of each angle. So what would be the angle ECF? How many degrees? 70, and why?
Because CBG is the same.
Okay, and so what was that just called?
Corresponding angles.
Corresponding angle postulate says that they would be the same. So there's a reason and there's the degrees. What's the measure of angle DCE? And we just found this one to be how much? 70. So if that's 70, what's this one? 110. And what's a reason we could use to get there?
Because of linear
Okay, what'd you say?
linear pair.
Linear pair theorem. Okay. Now it's not alternate interior angles because the angle DCE is an exterior angle, and that was an interior angle. All right. How about DCE, but now I've got variables. I've put some different information in here. How would we figure out DCE's measure?
5x equals 4x plus 22.
So you said set them equal to each other. Do you have some support for why you do that?
They both equal each other though. because of
Why do
the
they both equal each other?
linear pair theorem.
Now, these two are not
They're
linear
supplements.
pairs, and linear pairs are supplements anyway, so that's not the reason. You're correct that you would set them equal to each other. Help him out with his support. Kelsey?
Corresponding angles there.
And that one's the postulate. Corresponding angle postulate said corresponding angles are congruent when the lines are parallel. Are the lines parallel?
Yeah.
Yes, it was given in the picture. Okay, so you would set them equal to each other and solve, and then substitute in 5 times 22, this angle was 110. All right. And that one's probably easier yet. Oh, but look at what angle I'm asking you. It's not where the X is. I was tricked. QRS, this is the angle we want. So what is X? First of all,
118.
it's 118 by the corresponding angle postulate. And then if that's 118,
This one.
62 subtracted from 180. So we had to use a couple steps. Let's see what I'm doing on my solutions here. I'm giving you the reasons, like in a proof, what postulates or what theorems we're using. Okay, and if you have one angle, 90 degrees in this parallel lines and transversal, realize if that's 90, all of them would be 90 in both places. Okay, then we did the alternate interior angles. Alternate exterior angles, did you see it switch slightly? Alternate interior, and it went alternate exterior. Notice that the alternate exterior angles are also congruent. So get your notes on that third theorem. The alternate exterior angles are congruent. And then look at the board, how about the last pair, same side interior angles? Again, it's kind of warm in here, maybe it's just me. The last pair, I want you to notice, are not congruent. Same side interior angles would be like this one and this one. What relationship do they have? Okay, they're 180, so they're supplements. So we start thinking that everything is congruent, but the same side interior angles are supplementary. They would add together to be 180. So the last theorem, same side interior angles theorem, the same side interior angles are supplementary. And notice the conclusion has the word supplementary. So if we want to get from there to the equation where they would add together, you're going to be using another reason. You would have to interpret the definition of what supplementary means. So it'd be 2 steps to get to our equation, actually. Okay, probably a few more examples to run through to make sure you're picking out the right relationship. Are they congruent or are they supplementary? And always watch for your parallel lines. Some are not quite done with their notes. Okay, let's go on. Find the measure of each angle, give the support for each measure. Okay, so talk to me, raise your hand and tell me which one you can figure out, and I wish I could write on there and let it stay. But tell me which one you can come up with and why.
On your paper or just
Just raise your hand and we'll go from there. Okay.
all of them?
All of them? Tell me.
Well, you can find angle 6 because it's the C word.
Corresponding angle with this one? So you're right?
It's a 62.
Okay.
Or
No?
72.
No,
it's,
you're getting things mixed up. Corresponding angles.
or no, it's 118.
Okay. It is 118. It's not corresponding angles for his reason. If he's going to angle 6 right now, what's his reason?
Or 1. Or 4.
What's his reason, Anthony? Why would this be 118? Vertical angles. Now, if he's saying corresponding angles, which angle should he be telling me? If you go from the 118, that's corresponding angle would be angle 2. So angle 2 is 118, angle 6 is 118. What else can you come up with?
Angle 5. Or angle 7.
7 is?
62.
Why?
Linear pair theorem.
Linear pair theorem. 5?
62.
62, because you could do vertical angle from what we just did, or linear pair theorem again. Have we talked about 4? What's angle 4? 118, reason?
Alternate interior angles.
Okay, he's doing the alternate interior angles with the 118. How about angle 3? 62, relationship with the 118 would be
Same side interior.
same side interior. Yes, you could have done a linear pair back here if you wanted to. I think we already said 2 was 118. How about angle 1?
60.
It is 62. It's not directly from the 118, but maybe get the 118, get angle 3, and then do vertical. Or maybe go 118 to angle 7 and then get it from there. So we can do a series of things. All right, we talked about all of those. Let's take a look at this and then we better do our quiz. Okay, how would we find x? This is more of an algebra type. Notice I've got x at various places. There's more than one way I think that you could do it.
2x minus 135 equals x minus 30. Or 2x minus 135 plus x equals 180.
Or,
Or
are you with him on what he's saying at all? Okay, first he
or
said,
x minus 30 plus x equals 180.
okay, he came up with 3 different ways. Okay, the first one was using the corresponding angle postulate. He said make those two equal. Okay, then he said these two added to be 180. That would be because of the same side interior angle theorem. And then the last part was linear pair theorem. Okay, so which one did I use? It's like I did the same side interior angles theorem. So I got x to be 105. Now how do I find angle ABF? You know what x is, right? So you can substitute x in to find this angle. All right, here's an easy one to put it in for, or even here. So if this x is 105, what's angle ABF? 105 because
Same side.
Corresponding angles.
corresponding angles. They are on the same side, but they're not both interior. And then angle FBC, the angle up here. What did we say this one was? 105? Then linear to it is 75. So you can get from one to the other, passing out a little bit. All right, so you're going from one to the other. Make sure that you're only applying these theorems when the lines are parallel. So the assignment will have a little bit from both sections. The first one was the lines are not parallel, but you were naming corresponding, alternate interior, and so on. The second one is when the lines are parallel and you're finding angles more. So let's write down the assignment. The quiz just has 8 questions on it. I didn't think it would take you very long, so we'll see if I was right. Page 148.